All right, so my next question that I wanted to go over is question number 25. And question number 25 gives us KSP, solubility product. KSP equals 6.60 times 10 to the negative sixth. And we are asked what is the molar solubility of PB, oopsies, that of PB BR2. And we have an expression that is, or we have our solubility constant expression, which is KSP equals PB 2 plus times BR minus squared. And we know this because our dissociation of PB BR2 as a solid is it's going to dissociate into PB 2 plus 2 BR minus. So this 2 is going to become an exponent. Now we have 6.60 times 10 to the negative sixth. But what we need to do is we need to come up with an ice table where we have ICE. We have an excess of this, and this is going to, that solid is going to be minus X. We do not count the amount of our solid at equilibrium, but what we can say is our initial concentration of PB and BR2 is 0 and 0. This is going to be plus X. This is going to be plus 2X. And so that's going to give us X and 2X at equilibrium. So we're going to be able to rewrite this KSP as equal to X times, and this is in parentheses, 2X squared. Now, what that's going to mean is we've got 6.60 times 10 to the negative sixth equals 4X cubed, because 2X squared becomes, this right here becomes 4X squared times this other X over here equals 4X cubed. So then we'll take that 6.60 and we will divide it by 4. And then we'll also take, so divide by 4, the cube root of this. And what we're going to get is we're going to get X equals 0.0118. Okay, so that right there is going to give us our concentration of our, well, of our PB. And we can plug that in to get our BR minus concentration. Okay, so that gives us X. Now that's all good and great and everything like that. But what we want to do is we want to be able to use that to then answer the second part of the question. The second part of our question asks, what is the solubility? And this is the second of 3. So I'm going to go ahead and clear all this. Actually, I'm not going to clear all of them. Now the question is, what is the solubility of this in a solution of 0.5 molar KBr? And so now what we're basically asked is to answer how much would a solution of KBr, thus 0.5 molar, impact the solubility of this. And so we're going to do another PB BR2, which will dissociate into PB 2 plus 2 BR minus. We'll do another ice table. ICE, our initial concentration. So what we have effectively is we have a new solution and it's 0.5 molar KBr, and then we add some potassium bromide to it, or sorry, not potassium bromide, we add some lead bromide to it. What happens to that lead bromide? Well, in that solution initially, we already have 0 molar PB. We have 0.5 molar bromide though. And so excess, still that solid is going to dissociate. It's going to break down. I'm going to say plus X plus 2X. And so what this is going to mean is we're going to end up with X, and then we're going to say 0.5 plus X. Or plus, sorry about that, plus 2X. Okay, so now our KSP expression looks the exact same. I'm going to set it over here. KSP equals PB 2 plus BR minus squared. I'm going to say this is equal to X, and this is going to be equal to 0.5 plus 2X. We're going to square that. Now, what we can do with this is, or one of the assumptions that we can make is that X here is relatively small because of the magnitude of our KSP value, which is again 6.60 times 10 to the negative 6th, And so we can rewrite this as X times 0.5 squared. So essentially this plus 2X, we can basically mitigate that. We don't have to worry about that. Now, what we're going to do with this is we're going to plug all this in so that we can solve for X. And we're going to be able to rearrange this to be X is equal to 6.60 times 10 to the negative 6th over 0.5 squared. Now, after doing the math for this, you'll see that X is equal to 2.64 times 10 to the negative 5th molar. Okay, so that's the second part of our problem. The second chunk of it. Now, the third chunk of it. Now, before we go on to the third part, I want to kind of talk about these two numbers that we solved for. When we looked at the molar solubility of our PB BR2, and then we looked at it in this KBr solution, our number went from something like from like 0.0118 to 2.64 times 10 to the negative 5th. What this tells us is that our PB BR2 is much less soluble in the KBr solution. So the magnitude of this number is very important. And ultimately, the next part of our question is, well, let's say that rather than a KBr solution, we used a 0.5 molar PB NO3 2 solution, a lead nitrate solution. What would happen to our solubility if it was lead ions that were already in there as opposed to bromide ions? So we've got the same expression, PB BR2, and that goes to PB 2 plus 2BR minus. We've got an ice table. I, C, E, excess. In this, we're starting with 0.5 molar lead. We're starting with 0 bromide ions. Our change is going to be minus x minus, sorry, plus x plus 2x. At equilibrium, we're going to have 0.5 plus x, and we're going to have 2x. Okay, so now we're going to take this same expression that we have over here, and we're going to do the exact same thing, but we're going to make some tweaks to it. So our KSP is still 6.60 times 10 to the negative 6, because we're asking about how much of that PBBR2 goes into solution. That's equal to PB2 plus BR minus squared. Here, this PB2 plus is going to be 0.5 plus x. BR is going to again be 2x squared. Now what we can do is just like we did over here. We can drop the plus x. So this is going to be 0.5. This is going to be 4x squared. That's equal to 6.60 times 10 to the negative 6. And when we divide this by, oopsies, divided by 0.5 is 4, we're effectively dividing by 2, but that's going to give us, taking the square root of this side and the square root of this side, 0.5 times 4. That's going to ultimately give us x is equal to 0.00182 molar. So now the question is, well, what made our salt less soluble? What made our salt more soluble? And if we compare our solubilities, what we saw was that, you know, by having either the lead or the bromide present in the solution before adding the solid, our substance was much more soluble. You know, the KBR had a greater impact on reducing the solubility of our PBBR2. The lead nitrate didn't have as dramatic of an effect. And why is that? Well, because we're dissociating to 2 bromide ions as opposed to 1 lead ion. All right, I hope this is helpful, and have a good one.